Okay, let's talk about something wild. You know the Higgs boson, right? One of the biggest discoveries in modern physics? What if I told you it could have been predicted like decades earlier with just geometry? That's it. Today, we're going to dig into a really radical framework that claims it can do exactly that, and it kind of redefines reality itself in the process.
Yeah, let's just jump straight into it. For a minute, forget everything you know about particle colliders, quantum fields, all that stuff. What if the Higgs boson, the famous God particle that's supposed to give everything mass, what if it isn't even a particle? What if it's just an unavoidable outcome of pure, simple geometry? So, this pretty wild claim comes from a theory called the Universal Fractal Resonance Framework. We'll just call it UFRF. It's a lot easier. And believe me, its main idea doesn't just nudge physics, it tries to knock over the whole foundation. Okay, so here's the absolute core of it. UFRF says there are no fundamental particles. None. No little building blocks making everything up. So you can forget the standard model's, whole zoo of different particles. Instead, this theory says everything, and I mean everything we see, from light to matter, it all comes from just one single process, a self-sustaining electromagnetic vortex. All right, the big question, right? How could one single process possibly create, well, everything? The theory actually lays out a very specific geometric recipe for how reality boots up, right from the very beginning. So it all starts with something the framework calls a fundamental trinity. Think of it like this. First, you have a neutral point that starts to spin. That spin creates an electric field, and you can just picture that as a straight vertical axis. Easy enough. Then, at the same time, you have two opposing forces, one pushing out, one pulling in, and they rotate to create two flat magnetic field planes that are perpendicular to each other. And here's a really key point. The fact that the electric and magnetic fields are perpendicular, that's not a coincidence. The theory argues it has to be that way. It's a geometric necessity. Why? Because one field comes from a one-dimensional line, an axis, and the other comes from a two-dimensional flat surface, a plane. Geometrically, they just have to be at right angles. Now, this vortex isn't some chaotic mess. Not at all. It follows a really strict set of rules. It evolves through a repeating cycle that's always exactly 13 steps long. Let's take a look at how that cycle actually plays out. So this table kind of breaks down the whole life cycle. You can see the fields are born in the seed phase. Then they amplify, get stronger, then they harmonize, find a balance, but I want you to really focus in on position 10. Something super important happens right there, just before the cycle finishes up and starts all over again. Okay, that special moment at position 10, it's called the rest point. It stands for Resonant Energy State Translation. This is the exact moment when the electric and magnetic fields hit a perfect balance. And when that happens, it's like a gateway opens up, allowing energy to flow super efficiently between different scales of reality. Seriously, this gateway idea, it's the key to this whole thing. And this energy transfer isn't just efficient. The theory says it's actually geometrically enhanced by a very, very specific number, the square root of the golden ratio, phi. That's about 1.272. And this isn't just some number they pulled out of a hat. It supposedly emerges naturally from the geometry of the vortex itself right when it hits that rest state. Okay, you with me so far? We've got a vortex. It's got a 13-step cycle. Seems pretty straightforward. But now we get to the part that really bends your brain. This is the theory's biggest twist. The idea that we can't actually see this reality directly, like at all. Our perception is fundamentally warped. So UFRF's big claim here is that we never ever see the true geometric reality. What we see, every measurement we take, is just a projection. The best way to think about it is like, imagine you have some complex 3D object and you shine a flashlight on it. All you can ever see is its flat 2D shadow on the wall. Sure, the shadow tells you something about the object, but you're missing the whole picture, right? Well, according to this theory, that's how we see the entire universe. This sets up a really important difference. On one hand, you have the intrinsic reality. That's the pure, real deal, the unfiltered geometric value of the vortex. But then you have the observed reality. That's the shadow on the wall, the thing we actually measure with our detectors and telescopes. Let's use a real example to make this a little less abstract. The theory actually calculates one of the most famous numbers in all of physics, the fine structure constant, using nothing but its own geometry. And it predicts that the true, intrinsic value, should be exactly 137.036303, and so on. But here's the thing. When physicists in the real world go and measure this constant, they get a slightly different number. They get 137.035999. So what gives? Does this mean the theory's just wrong? Nope, not even close. According to UFRF, that tiny little difference is the entire point. That difference is the exact size of the shadow, the projection effect, that the theory predicts. So the fact that our measurement is a little bit off is actually used as evidence that the whole projection idea is right. Kind of clever, right? Okay, so let's take this exact same logic and apply it to the Higgs boson. All right, time to bring it all home. We've got the vortex, we've got that special rest point in its cycle, and we have this idea of a projection law. With those three pieces, we can finally get to the main event, predicting the Higgs boson. So what exactly is the Higgs in this new picture? Well, the theory says it's not a particle at all. It's a, and this is the quote, projected standing wave resonance in that vortex. The best way to think of it is like plucking a guitar string. The sound you hear, that specific note, it's a stable vibration, right? It's not a separate little thing that flies off the string. It's a resonance. That's what the Higgs is here. Let's unpack that a little more. The UFRS version of the Higgs is just what happens when the vortex hits that rest point, but down at the quantum scale. It is that stable vibration, that resonance, and that is the mechanism that lets the pure energy of the vortex show up as what we see and measure as mass. And this isn't just a vague idea. The theory makes a hard numerical prediction. It says that based on its geometry and nothing else, the true intrinsic mass energy of this Higgs resonance should be right around 124.025 GeV. That's just the unit they use for this stuff. But hang on a second. If you follow physics, you probably know that the number from the Large Hadron Collider is different. The measured mass of the Higgs is about 125.1 GeV. So is the theory just wrong? I mean, it's off by about a whole GeV. That seems like a big deal. And this, right here, is the entire payoff. Just like we saw with that fine structure constant, the theory's answer is a big, fat no. That 1 GeV difference, that's not an error. That is the prediction. It's the exact size of the shadow, the projection effect, cast from the quantum scale up to our human scale where we measure things. The thing that looks like a mistake is actually what the theory says is its biggest proof. So if you just step back and think about it for a second, the implications here are, well, they're huge. If a framework like this is even a little bit right, it totally reframes how we think about what reality even is. And it really leaves us with this one massive question. Is the universe made up of a bunch of separate things, particles, forces, all following their own weird laws? Or could it all be one single unified geometric process, a kind of cosmic vortex, and we're just seeing small projected shadows of it? It's a completely different way of looking at, well, everything.